In this video, I'll be talking about reaction mechanisms. So reaction mechanisms allow us to see a scheme of a reaction that ultimately culminates in the overall reaction. Very rarely do reactions happen as we write them. They typically happen in a sequence of steps, with some of those steps being faster or slower than others. We really want to take note of the slow step of a reaction mechanism because this slow step is known as the rate determining step. And this is the most important step when it comes to understanding how quickly this reaction takes place, because the rate determining step sets the pace for the reaction overall. And it's going to affect the kinetics of the reaction much more than the two or more fast reactions that you have. So, when you want to write a predicted rate law for reaction schemes or reaction mechanisms, you want to take into account the reactants that you have up to and including the slow step. So that's going to be these two NOs here. We're not going to worry about the N2O2 because it cancels. And then this H2 right here. We're not going to worry about this last step because this last step comes after the rate determining step. We only want to concern ourselves with the reactants that come before and during the rate determining step. So if we wanted to write a predicted rate law, we would set the rate equal to the concentration of these NOs raised to the second power because there's two of them, and the concentration of the H2 raised to the first power because there's only one of them here. So this would be our predicted rate law for this reaction. We would have to use experimental data to determine whether this predicted rate law holds true or not. Sometimes they do, sometimes they don't. Then we want to concern ourselves with this question here. What are the reaction intermediates? Intermediates are going to be compounds that show up in the steps of your mechanism, but don't show up in the overall reaction once it's finished. So in this reaction, we see a couple compounds that are in here, but they don't show up in the final reaction. And those are going to be the reactants or products that are the same on both sides of the arrows. So it looks like here we have N2O2, and down here we have N2O2. They're on opposite sides of the arrow, so they cancel. So that's going to be one of your intermediates, because it doesn't show up in that overall reaction. And then N2O, same thing. There's one here on this side, there's one here on this side. Doesn't show up in the overall reaction, therefore we can consider it an intermediate. Like that. And the rest of the compounds show up in the overall reaction, so those would be our two intermediate compounds, N2O2 and N2O. What is the rate determining step? Well, we kind of determined that earlier. The slow step of your reaction mechanism is always going to be the rate determining step, RDS. Always going to be the slow step. And then which step would benefit from the use of a catalyst? Well, catalysts are compounds that speed up reactions. And if we wanted to speed this reaction up, we would need to target the rate determining step. And that's because the rate determining step is what sets the pace for the reaction. So if we wanted to increase the rate, we would target the slow step with a catalyst. So if we wanted to speed this reaction up, we would throw a catalyst into this slow step up here, and that would increase the rate at which this reaction takes place. Catalysts work by lowering the activation energy required for a reaction. So that's about all I can say about reaction mechanisms. They basically just show you a sequence of reactions that ultimately builds into an overall reaction. Main takeaway here is the slow step. The slow step will always be your rate determining step.